Good evening, all. I welcome you all on the behalf of StudyIQ IAS English. My name is Pritesh Maturkar. I extend my warmest regards to those who are watching me live and also those who will be joining me on a later date as per your convenience. So, I extend my warmest regards and I have faith that you all are trusting me as your able friend, philosopher, and guide, wherein I take you on a world tour, wherein we analyze the physiography of our beautiful planet, wherein we appreciate the beauty of our earth using the most potent tool, that is maps. So the typical workflow of this classes is that in the first few minutes I discuss whatever we have discussed in the previous classes. So this being a continuing series, today being lecture number 19, we have covered a lot amount of distance. So thank you that you have trusted me and that you are continuing to trust me, and I have faith that you will do that in the future too. Okay, so we discuss some of the important concepts after the revision, and after that I tend to showcase you on the atlas. So this has been the typical flow of this lectures. So using this content, I intend to cover roughly 50 to 60% of your geography GS discourse, and I tend to cover roughly 10 to 20 marks in your prelims and approximately 100 to 200 marks. And if GS paper 3 comes in our purview, and if essay comes in our purview, then we can extend it way further up to 400 to 500 marks too. Okay, but for that we require all the stars shining brightly upon us. So I hope that that does happen someday. Okay, and someday in the sense the day when you give your mains. Okay, so in this series, in this endeavor, I have been detailing some of the important locations of the earth. I have been detailing some of the concepts of the geophysics, which I feel are important from mapping perspective. So yet we have not started the detailed analysis of maps. Detailed analysis of maps will follow once I am sure, once I am confident that I have given you the base for understanding the maps, that I have elevated your level from basic understanding to a little bit of higher understanding. So for this, first we finish up the climatology part. Now I am venturing into the lithosphere, into the geomorphology part, and I will be also discussing a little bit of hydrosphere, the oceanography with you. Then only we will begin the detailed analysis of maps of the world per se. Okay, so I welcome you all formally to this endeavor, this being the 19th session. So let's start from where we left yesterday, and as I promised that each session will begin with a beautiful image of a location which we covered in the previous class. So the beautiful image which you see behind me on this interactive flight panel, this image is of the Katinga Plateau. Sorry, this image is of the Kimberley Plateau of Australia. Okay, so Kimberley of Australia and Katanga of Africa, they resemble a lot, but this is basically the Kimberley Plateau region of Australia. As you can see over here, the rocks which you find over here, these are primarily granitic and dioritic, and each of these rocks is approximately 3 billion years old. Okay, the entire Western Australia is a shield region, and in that primarily the Kimberley topography dominates. So the individual rock piece which you see over here, they are primarily 3 billion years old. So very old, very ancient topography, but as it is exposed, so it is a shield region. And Kimberley is very important region for coal. It is very important region for thorium. Okay, in fact it is called as the grade A anthracite coal. Okay, so let's start our today's discussion. Let me just do a quick recap of what we did yesterday. So yesterday I introduced you to the interiors of earth. In the interiors of earth, we did study the two bases. The first basis we studied was on the basis of chemical properties. So on the basis of chemical properties, the interiors of the earth can be layered as crust, mantle, and core. The continental crust will extend up to 60 to 80 kilometers in depth, whereas the oceanic crust is barely 1 to 3 kilometers in depth because majority of it is underwater. Below that, up till a depth of 20 and 100 kilometers, you predominantly have mantle, and after that you have the core. Okay, the outer core and inner core, they separate at around 4800 kilometers, beyond which lies the inner core. And current affairs wise, guys, okay, this year for the first time we have discovered another true inner core inside the inner core. How it has been discovered? It has been discovered to seismic wave analysis. So you need to keep in mind whatever is happening in the geology field, whatever is happening in the geography field, what is happening in the physiography of earth per se with regards to current affairs. And I, as your able mentor, philosopher and guide, it will also be my zeal that I interlink current affairs with you all. Okay, because geography as a discipline is all about two things. Number one, locational analysis, and number two, its interlinkage. And for interlinkage, you do require heavy understanding of what is happening now, because geography as a discipline is heavily reliant on technology. The more we have technological innovations, the more we have technological advancements, the more we try to understand the earth, and the more our basically working of our planet and the universe improves. Okay, so let's start from where we left yesterday. So let us do the interior or the layering of earth based on the mechanical rigidity of the surface. Okay, so I'm doing the second classification. We are doing the interiors of earth. Now we will be discussing the interiors of earth on the basis of mechanical rigidity, on the basis of mechanical on the basis of mechanical strength or mechanical rigidity. Okay, so what do you mean by rigidity? Okay, rigidity is basically the level of hardness. Okay, how easily a substance can be deformed. Very crude understanding. So if I'm applying pressure on this marker, is this marker getting deformed? No, this is rigid. But if I apply pressure on this rubber cap, will this rubber cap deform? Yes, because its rigidity is less. So similarly, we need to understand how is the interior of earth with regards to mechanical rigidity. So on the basis of mechanical strength or on the basis of rigidity of the surface, the interiors of the earth are distinguished into three distinct layers. So on the basis of mechanical rigidity, you have three distinct layers in the interiors of earth. Okay, the first layer being the lithosphere, okay, the second layer being the asthenosphere, okay, and the third layer being the mesosphere. Mind you, you also have a layer called as mesosphere in the atmosphere, but that layer and this layer is very different. So you have lithosphere, you have asthenosphere, and you have mesosphere. Okay, now let us try to picturize this layer in terms of their depth and what actually these layers translate into, and what is its correlation with continental drift. What is its correlation with continents being drifting from one location to another location, and how did you have the breakup of Pangaea, and how the Pangaea broke up into Laurentia and Gondwana land, and how do we have the present day arrangement of the continents. Okay, so if I'm moving the discussions ahead, so what is lithosphere, guys? So lithosphere is basically that layer which includes two things. Okay, so the lithosphere will include two things. Number first, okay, it will include the crust. Okay, it will include the complete crust. Crust will be both continental and oceanic. So it will include both continental as well as oceanic crust. Number two, it will include the upper part of the upper mantle, or it will include the upper part of the outer mantle till a depth of 100 kilometers. I'm again reiterating, the first thing which lithosphere will include, we are doing this layering on the basis of mechanical rigidity. On the basis of mechanical rigidity, the earth is classified into lithosphere, asthenosphere and mesosphere. What does lithosphere include? Lithosphere includes the crust both continental as well as oceanic. So it will include both continental crust as well as oceanic crust. And second, it will include the upper part. It will include the upper part of upper mantle. It will include the upper part of upper mantle or the outer mantle. The upper mantle or the outer mantle till a depth of till a depth of how many kilometers? Of around 100 kilometers. Till a depth of 100 kilometers. So this is the extent of the lithosphere. It will include both the continental crust and the oceanic crust. Okay, the thickness of continental crust is up to 60 to 80 kilometers, and the thickness of oceanic crust is between 1 to 3 kilometers, and it will include the upper part of upper mantle till a depth of how much? Till a depth of 100 to 300 kilometers. So this is our lithosphere. Okay, and what is the extent of asthenosphere? So asthenosphere will extend from 100 kilometers. Asthenosphere will extend from 100 kilometers up to 300 to 400 kilometers. Up to 300 to 400 kilometers. So that will be the extent of asthenosphere. Okay. So let's move ahead. And beyond 400 kilometers, beyond 400 kilometers, you will have the mesosphere. Okay, but you also have a distinct layer of mesosphere. So if the core is identified separately, then you also have another layer called as barysphere, but you don't need to worry with regards to that layer. Just remember that anything beyond 400 kilometers, it will be predominantly called as mesosphere. Okay, so now let us go into details and let us understand what this actually translates into, actually what it basically translates on the surface and what is its relation with plate tectonics. Okay, so chemically speaking, guys, if we think the lithosphere, okay, so the lithosphere is not a completely solid layer. It is broken into different fragments. It is broken like a eggshell. So if you have a egg, if you have a boiled egg, and if you have a shell around it, and if you break that shell, so you can see cracks on the eggshell, and that cracks on the eggshell will represent different fragments of the egg. So similarly, what is lithosphere? Lithosphere is like a broken eggshell. So the lithosphere is broken into segments. The lithosphere is broken into fragments, and each of these segments, it is called as lithospheric plate. Okay. So the lithosphere is not a continuous layer. The lithosphere is not a continuous layer. Okay, it is broken. Okay, it is broken, guys. Okay, it is broken like a cracked eggshell. It is broken like a cracked eggshell. Okay, it is broken like a cracked eggshell. So if I am trying to showcase you diagrammatically, okay, so if this is our lithosphere like this, okay, let us use a 3D diagram, okay, for our better understanding. Okay, so if this is our lithosphere and this is the lower layers of the earth like this basically, okay, so the lithosphere is broken. Okay, it is broken as different segments. So this is one segment, this is another segment. So the lithosphere is a broken layer. It is somewhat like this. Okay, each of this fragment or each of this layer is broken. Okay, it extends down like this. So each of this fragment is broken. Each of this individual fragment, each of this broken individual part of the lithosphere. So if I'm considering this part, 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 or this part, each of this fragment, each of this fragment, each of this broken shell, okay, this is called as lithospheric plate. This is called as lithospheric. This is called as lithospheric plate. So please keep in mind that each one of these broken fragments, okay, each one of this cracked part of the lithosphere, this is we called as lithospheric plate. Okay, please keep this in mind. Okay, and mind you, the lithosphere is not a continuous layer. It is not as rigid. Okay, it is broken into fragments, and each of these fragments, they are called as lithospheric plates. And you can have these lithospheric plates as continental plates or as oceanic plates. You either have the lithospheric plates being broken into continental plates or as oceanic plates. So you will have two types of lithospheric plates in the world. You will either have continental plate or you will have oceanic plate. Okay. Now let's move ahead. Let us consider the asthenosphere. Now this lithosphere is sitting upon the asthenosphere, and as you know that asthenosphere is that layer which includes the upper part of the upper mantle till a depth of approximately 100 kilometers. Okay, so beyond that, beyond the upper part of upper mantle, beyond that 100 kilometers, you have the beginning of asthenosphere till a depth of around 300 to 400 kilometers. So we have crossed the crust, we have crossed the boundary of the crust and mantle, and now we are going into the depths of the outer mantle. So as you go into the mantle, which mineral will dominate? So remember, we discussed the different minerals of the silicates, because predominantly we have to study the silicate minerals. Why? Because if you consider the earth as its crust, the dominating elements are elemental O2 and silica. So it but naturally becomes that we have to keep our focus on the analysis of silicate minerals. Okay, hence if we go into the outer mantle, or if we reach to the boundary of crust and mantle, the dominating mineral is olivine and the dominating mineral is pyroxene. So if you consider asthenosphere, if you consider the asthenosphere, this asthenosphere will predominantly have what? Which mineral will be there predominantly in asthenosphere? This asthenosphere predominantly this asthenosphere predominantly will have what? It will predominantly have olivine. It will predominantly have olivine. Okay, and you all know what is the property of olivine? What is the property of olivine? Olivine tends to lose rigidity. Olivine tends to lose rigidity under sustained. Olivine tends to lose rigidity under sustained stress. So because of this, the asthenosphere, because of this, the layer just below the lithosphere, it is not completely solid. It is not solid. Rather the asthenosphere is semi-molten. The asthenosphere is semi-molten. So please remember this, guys, that the asthenosphere is not rigid. It is not a completely solid layer, rather it is semi-molten. Why is it semi-molten? Because you have dominance of which mineral? You have dominance of olivine, which tends to lose what? Which tends to lose rigidity under the sustained stress. Okay, and because of this, the lithospheric plates, they start floating over the semi-molten asthenosphere, and that is why you have drift. You have drift of what? You have drift of the lithospheric plates over the semi-molten asthenosphere. So this is our first correlation with the interiors of Earth and the drift of the continental plates and the oceanic plates. So please get this point very properly. So each of the lithospheric plates, each of the lithospheric plates, okay, each of the lithospheric plates will drift, will drift, will drift on the semi-molten, on the semi-molten, on the semi-molten asthenosphere, on the semi-molten astheno, on the semi-molten asthenosphere. So each of this will drift on the semi-molten asthenosphere. So this explains us how the continents were first situated somewhere, how the continents broke, and how the continents drifted apart. So you got the answer that how can continents drift? Because they are floating over the semi-molten asthenosphere. Now you must be wondering that what is the driving mechanism? Okay, and how are these plates actually drifting? Okay, so the answer to this, the answer to understanding that what are the driving mechanisms to this. So the driving mechanism was suggested by a person called as Arthur Holmes. Okay, so let us understand what is the convection cell hypothesis of Arthur Holmes and how it basically results into the drifting of the lithospheric plates, because that is very important for you to understand how this drift actually happens and where you have divergence of these plates and where you have convergence of these plates. Because whenever we will do the atlas, whenever we will do the atlas entries, so we need to understand in which parts of the world we have convergent boundaries where two lithospheric plates basically they collide, and where in the world you have divergent boundaries where the two lithospheric plates they diverge out. Okay, so before going into that, let us have an in-depth analysis of the lithospheric plates. Okay, what are the lithospheric plates, what are their types, and we will do the examples on the atlas. Okay, so if we want to discuss the lithospheric plates if we want to discuss the lithospheric plates, okay, so lithospheric plates are divided into two. You can either have continental plates, you can either have continental plates, okay, or you can have what plates? You can have oceanic plates. You can have continental plates or you can have oceanic plates. So you have two types of lithospheric plates. You can either have continental plates or you can have oceanic plates. In general, as a rule, in the world, you don't find continental plate and oceanic plate basically very much separated. Normally, you find a amalgamation of C plus O. So C plus O means you will have a continental plate and ahead of that you will have the oceanic margins. But mind you, the continental plates are altogether different from the oceanic plates. This is a very important point, guys. Okay, continental plates and the oceanic plates are entirely different. Continental crust is different from the oceanic crust. Continental crust once formed can never be destroyed, whereas the oceanic crust of the earth, it undergoes recycling. Mind you, this is very important. Okay, the continental plates, they can never be destroyed. Okay, they are fundamentally different. They are fundamentally different from the oceanic plates. Okay, continental plates are buoyant, they will resist subduction. Once they are formed for eternity, whereas the oceanic plates, they undergo recycling. So they are formed, they are destroyed, and they are recycled. Okay, so please keep this in mind, that what do you mean by this? Okay, there is a cycle called as Wilson cycle. So continental crust, okay, continental crust or continental plates. Okay, once formed, okay, once formed, okay, once formed can never be destroyed, can never never be destroyed. Okay, destroyed in the sense that unless and until you have very big seismic event, you have some another asteroid coming and striking the earth crust, then only the continental crust can get destroyed. Otherwise it's very difficult for continental crust to get destroyed. Okay, continental crust, as its density is between 2 to 2.5, it is lighter than the oceanic crust, and therefore it will resist what? It will resist subduction. It will resist subduction. Okay, subduction means what? It will get not pulled into the mantle. So continental crust cannot get pulled into the mantle. Why? It is light, it is buoyant, its density is less, hence the continental plates will resist subduction. Whereas if I'm considering the oceanic crust, whereas if I'm considering the oceanic crust, okay, then the oceanic crust density is around 3 to 3.5. It is denser. Okay, it can get subducted, it subducts. Okay, it subducts. Where it subducts, we will explain you in a short period of time. So where it subducts, it's basically the trench locations of the world. So whenever we will do atlas, so trench locations are very important locations for us, because there the oceanic crust basically subducts, it gets pulled into the mantle, and where it gets pulled, it gets destroyed, it completely melts, and there it again gets recycled. Okay, so the oceanic crust subducts. Okay, it can get recycled. Okay, it can get recycled. It can get recycled, and this recycling, it is called as Wilson cycle. It is called as Wilson cycle. So for now guys, just remember this, that the oceanic crust can subduct, it can melt, it can get recycled, and the name of the cycle in all of this process, the entire process is called as what? The entire process is called as Wilson cycle. Okay, so continental crust, let's be very sure, the continental crust can never be destroyed, whereas the oceanic crust gets subducts, it gets destroyed, and it gets recycled. So it is called as Wilson cycle. Okay, so this thing is clear to you now. Now let's move ahead and let us discuss the major plates of the world, so that you have a bird's eye view that what are the major plates of the world and how you have the orientation. So as a rule, I told you that you will not have continental plate separate and oceanic plate separate. Okay, you will have some combination of continental plus oceanic normally, but you have examples in the world where you have purely continental margins or you have purely oceanic margins. But as a rule, not as a rule per se, I'm correcting myself, but in general, I'm not saying as a rule, in general you may find C plus O. It's very difficult to find individual C existing and individual O existing, but there are examples. Okay, the biggest plate of the world itself is the Pacific plate, and it's purely oceanic plate. Okay, so there are always exceptions to everything, and it's life, so always there will be, so it's nature. In life there are exceptions, so in nature it's but natural that you will have exceptions. Okay, so let us understand this now. Let us move ahead and let us try to paint the major continental plates and the oceanic plates of the world. Okay. I'm just opening the PDF so that you get a bird's eye view of what we are talking. Okay. Okay. let's open it in this only. Okay, I'm adding up the map of the plates. Okay, so let us use the atlas over here. Okay, so in this you do have the plate tectonics. Okay, yeah, so don't worry, this is written basically in Japanese, but you don't worry, I will write everything for you down in English. Okay, so let's use the interactive flat panel to its best extent and let us try to analyze the plates of the world. Okay, don't worry that you must be wondering that I have opened up Japanese. So basically this is the plate boundary map given by WWSSN of Japan. Japan is the world's most pioneering country in geomorphological research because on an average, Japan gets more than 1,000 earthquakes a year. So if you go to Tokyo, on an average, Tokyo, the most populated city in the world, every day it will experience 3 to 4 earthquakes. Okay, so let us try to paint the picture of the plate tectonics. So I'm just mentioning you the different plates and I will be jotting down their names too. Okay, so first of all, I will be discussing the continental plates of the world. I am not discussing the oceanic plates. I am first discussing the continental plates. And again, you have two major groupings in the plates. You have major plates and you have minor plates. So the lithospheric plates are grouped into two. You have the major plates, you have the minor plates. The lithospheric plate, you can either have continental plate and oceanic plate. So continental plates can be grouped into major plates or minor plates. The oceanic plates can also be grouped into minor plates and major plates. So let us first understand the major plates of the world. And in that major plates, I will be discussing a combining of continental plate and oceanic plate. So I am grouping the plates as major plates and minor plates. So the first major plate of the world, I discussed that I'll be moving from west to east. So the first major plate of the world is the Pacific plate. So this, don't focus on this. So this is the Pacific plate. So you can see over here the Pacific plate extends from west to east because the earth is round. So this is our first plate. This is called as Pacific plate. Okay. So first major plate of the world that you have, you call it as Pacific plate. Okay, so the first major plate of the world, it is what? It is called as the Pacific plate. So if I'm discussing the major plates of the world, okay, so in major plates, the first plate I'm discussing is the Pacific plate. But mind you, the Pacific plate is purely oceanic, plate. Okay, and also the Pacific plate is the world's largest plate. The Pacific plate is the world's largest plate. So please keep this in mind that the Pacific plate is the world's largest oceanic plate as well as it is the world's largest plate. So this one I have written over here. So this is our Pacific plate. Okay. The second most important plate that you have, it is called as the Eurasian plate. Okay. So this complete plate of the world over here, this is called as the Eurasian plate. This is called as the Eurasian plate. Okay. So Eurasian plate is the world's biggest continental plate. So if I'm discussing the second plate with you all, the second most important plate, it is called as the Eurasian plate. It is called as the Eurasian plate. It is called as the Eurasian plate. Okay. If I'm painting you on a world atlas, okay, let us try to paint it also on world atlas so that you get a bird's eye view. Okay. So if I'm painting on the world atlas for you all, this complete part, okay, this part and this part is where you have the Pacific plate. So this is our Pacific plate. Okay. This complete part of the world over here, okay, this is called as the Eurasian plate. So this is our Eurasian plate. Okay. Then if I'm discussing the next plate with you, so the next plate is called as the North American plate. So this complete plate, okay, this plate, okay. Okay, so this complete plate that which I'm showcasing you on the board, devoid of the South America. Okay, so you have two distinct plates. So this plate this is called as North American plate. Okay, and mind you, this is what plate? This is continental plate. This is not purely oceanic. So the boundary between the Eurasian plate and the American plate is like this. So continental plate will have its oceanic front. So this is the oceanic front of North America. So this is C plus O kind of thing. This plate, it is called as South American plate. So South American plate will also have its oceanic boundary. So it is again C plus O. So you have the North American plate, you have the South American plate. Okay, so the third plate that I'm discussing with you all, it is called as the North American plate, and the fourth plate I'm discussing with you, it is called as the South American plate. Okay, the Eurasian plate is the world's largest continental plate. Okay, it is the world's largest continental plate. Which is the world's largest plate? The world's largest plate is the Pacific plate. Which is the world's largest oceanic plate? It is again the Pacific plate. The world's largest continental plate, it is the Eurasian plate, and it is also the world's biggest expanse of continental crust. Okay, then we discuss the North American plate, and then we discuss the South American plate. Okay, so if I'm showcasing you on this board, okay, so this is our North American plate. This is our North American plate. Okay, this complete plate like this is our North American plate. This complete plate down south, this is our South American plate. Okay, so for your reference, I'm again using this atlas. So South American and North American. Okay, the next plate that you have, this is called as the African plate. So this is the African plate, next major plate. Okay, so the next plate that I'm discussing with you all, it is the African plate. So number 5th plate, you have the African plate. Okay, you have the African plate. So North American, South American and African. If again I'm showcasing you this complete plate of the world, okay, wherein you have the African landmass. So this complete plate, this will be called as the African plate like this. So this is the African plate, another major plate of the world. And the last plate that you are remaining is called as the Indo-Austral plate. The last plate, it is called as the Indo-Austral plate. If I'm showcasing you on this over here, so this plate now which you are remaining, this complete plate, this is called as the Indo-Austral plate. It will include Australia, it will include India, it will include the Arabian part too, but mind you, this plate is a different plate. So it will not include this part. This part is a different plate. Don't focus on this atlas. You have the Indo-Austral plate. So India and Australia. And the last plate, you will have the Antarctic plate over here. So the last plate, it will be called as Antarctic plate. Okay. The last plate that will be having as one of the major plates of the world, you will be having as Antarctica. Okay, so the last plate that you have as a major plate, it is called as Antarctica. Okay, so you have the Pacific plate, you have the Eurasian plate, you have the North American plate, you have the South American plate, you have the African plate, and then you have the Antarctica. Okay, so these are, guys, some of the important major plates of the world. Now, if I'm discussing some of the important minor plates of the world, so let us also try to understand what are some of the important minor plates of the world. Okay, so if I'm painting you the minor plates of the world, okay, so minor plates, you predominantly have 5-6 very important minor plates. Okay, the first plate that you have, very important minor plate, it is called as Nazca plate. It is called as Nazca plate. The second you have, it is called as Cocos plate. It is called as Cocos plate. After that, you have the Arabian plate. You have the Arabian plate. Number 4, you have the Caribbean plate. Okay, Caribbean. Okay, Caribbean plate. Guys, all of these entries are very important. Why now? Because this will serve as the basis of your understanding of the detailed atlas of the physiography of that particular region. Okay, so don't worry, we will be going into the details of each of these entries later on when we'll cover up it through maps. So you have Caribbean plate, then you also have a plate called as Philippines plate. Okay, Philippines plate. Okay, Philippines plate is a very important plate, and again you have one very small minor plate. It is called as Juan de Fuca. It is called as Juan de Fuca. So I am basically naming you some of the minor plates of the world which are important for your understanding of the physiography of that particular region. And if I am showcasing you these plates on the world atlas, okay, how these plates are and where they are. Okay, so this part of the world over here, this is where you have Juan de Fuca. This is where you have Juan de Fuca. Okay, this plate. Okay, this is the plate where you have the Caribbean plate. Okay, Caribbean. And guys, all of these plates, okay, Juan de Fuca is basically this plate is purely oceanic. Caribbean plate is a mix of continental crust and oceanic crust. On the west coast of South America, here you have Cocos, here you have Nazca. Here you have Nazca. So Nazca and Cocos, both of them are primarily oceanic. This is Nazca. Here you have the Arabian plate. So this is our Arabian plate. You remember the breakup of Pangaea, the formation of Red Sea. So as the Red Sea broke up, the Arabian plate got separated. And lastly over here, you do have another plate. This is called as the Philippines plate. This is called as the Philippines plate. Okay, so you have Juan de Fuca, you have Coco, you have Nazca, you have Caribbean, you have Arabian, and you have Philippines plate. Okay, so guys, these are some of the major and minor plates of the world. Now you need to understand this, guys, this is very important, that what is the driving mechanism behind this, that how are these plates basically drifted from one location to another location. Okay, so for this we need to understand a theory called as the vertical convection cell hypothesis of Arthur Holmes. Okay, so let us understand that too. Okay, so what is vertical convection cell hypothesis of Arthur Holmes? So basically, according to Arthur Holmes, you have what? You have volcanism on Earth. We all have studied that Earth is basically was a giant hot nebula. That hot nebula is condensing. You have volcanism. You have formation of the one of the first primitive crusts of the Earth. So according to Arthur Holmes, you have what? You have vertical convection cells. You have vertical convection cells. Okay, what are these vertical convection cells? These vertical convection cells are nothing but plumes of magma. They are nothing but plumes of magma. Okay, plumes of magma, and these cells can either be converging, or they can be diverging, What do you mean by this converging or diverging? So just imagine that this is the surface of the earth like this. Okay, so this is our earth's surface. Okay, beneath this surface you have vertical convection cells. So you have the magma being thrown upwards like this because of underground volcanism. So either you can have a cell like this. This is called as diverging cell according to Arthur Holmes. So this is a mantle plume, this is another mantle plume, and this complete part, this is called as a convection cell. So this is called as diverging. This is called as diverging convection cell. This is called as diverging convection cell. And you can also have what? You can also have converging vertical cell. So you can either have the cells converging like this, or you can have the cells diverging like this. You can either have cells converging or you can have the cells diverging. So you can either have converging, you can either have diverging, or you can have converging. Okay, so beneath the surface you have this big mantle plumes which do what? They either perform the process of diverging or converging. Now just imagine the land surface above. If there is a diverging convection cell beneath the land surface, now what will happen? This will start to break apart, this part will start diverging over here, this part will start diverging over here. If you have a converging cell, so converging cell means what? Now this cell will carry this drifted off part from over here to here, and where the cell is converging, this part will be swallowed into the mantle. So you have rising up, you have diverging up, and then you have the converging. So depending upon which side of the diverging on converging is active, you can have the drift of the continental crust and the oceanic crust. So very crude understanding, guys, how everything operates under the earth. So I'm again reiterating, the lithosphere is broken into different fragments. It is broken into different plates. Okay, each of these plates, it is called as lithospheric plate. You have major plates of the world, you have minor plates of the world. Okay, so these major plates, these minor plates, they are grouped on the basis of their extent of area. So the major plates of the world will include the Pacific plate, Eurasian plate, African plate, the American plate, both South American and North American, Eurasian plate, and the Indo-Austral plate. Minor plates, Caribbean, Cocos, Nazca, Philippines plate. You also have the Arabian plate, Juan de Fuca. So minor plates of the world. You also have a plate called as Scotia. I have not discussed that plate, but it will eventually come when we'll do the physiography of South America. Okay, so these plates, they drift on the semi-molten asthenosphere, and what is their driving mechanism? Their driving mechanism is this: the vertical convection cell hypothesis or after Holmes, wherein beneath the surface you have this big mantle plumes. So these cells, they either diverge or they converge. So depending upon which side is more dominant, the diverging side, so the slab will be pulled on this side, or if they are converging, it will be converged and the slab will be pulled into the mantle where it will get destroyed. And predominantly over here, which crust will be swallowed? Predominantly the oceanic crust. So please keep this in mind, the oceanic crust is recycled. Okay, it subduct, it melts, and it gets recycled, and the name of the cycle is Wilson cycle. Okay, so here I stop for today. From tomorrow onwards we will begin from here only. So tomorrow I will explain you the basic of plate tectonics. From there on we will carry away our discussions further. So you can all reach out to me on Telegram. You can all reach out to me on a channel called as Geography by Pritesh Maturkar. For joining this, you can just do a global search at Geography by Pritesh. So if you join this channel, I can give you the most relevant tidbits with regards to the discipline of geography. I can give you the most detailed analysis of the current affairs on that channel. So it is my endeavor that I wish to cover everything in detail with you. So please join this endeavor. Okay. So on the behalf of StudyIQ IAS English, I extend my warmest regards to everyone. I hope that you all are doing fine and that you are working hard and smart. So thank you everyone for watching this. We'll meet tomorrow sharp at 5 p.m. Appreciate this. Take care everyone. Thank you.